Hey guys, in the last video we had discussed the basic trigonometric functions, that is sine, cos, tan, cosec, sec and cot. And in this video we're going to check out a few trigonometric identities. So I've drawn a sample triangle over here and we can refer to that. So now the first one which I'm going to show you is tan theta is equal to sine theta by cos theta. And we can prove this. So we know that sine theta is equal to opposite by hypotenuse over here, and cos theta is equal to adjacent by hypotenuse. Now to prove that tan theta is equal to sine theta by cos theta, we can simply divide these two values of sine and cos. So sine theta by cos theta is equal to opposite by hypotenuse into the hypotenuse by adjacent. Since we're taking divided by cos theta, we're going to take the reciprocal of this. And here we can see that hypotenuse and hypotenuse get cancelled and we get opposite by adjacent. And this is the value of tan theta as we saw over here. So this is one important formula to remember, that tan theta is equal to sine theta by cos theta. Now we also know that cot theta is equal to 1 by tan theta. So we can say that cot theta is the reciprocal of tan theta. So cot theta will be equal to cos theta by sine theta. And I hope that's understood. Okay, let's move on to the next identity, and this is probably the most common identity we're going to be seeing in trigonometry, and the identity is sine square theta plus cos square theta is equal to 1. Now if I draw my sample triangle again, where this is theta, this is opposite, this is hypotenuse, and this is the adjacent side. So now let's take the RHS first, I mean the LHS. So sine square theta plus cos square theta. And in terms of this triangle, we can say that sine square theta is equal to opposite by hypotenuse the whole square. So that is AB by AC the whole square plus cos square theta, and that is adjacent by hypotenuse the whole square. So that is, in terms of the sides of this triangle, it will be BC by AC the whole square. Now simplify this and we'll get AB square by AC square plus BC square by AC square. Now we can see that the denominators are equal, so we can group them together. We'll get AB square plus BC square divided by AC square. Now if you're familiar with the Pythagoras theorem, you know that the square of the hypotenuse, that is AC square, is equal to the sum of the squares of the other two sides of the right angle triangle. So here we have a right angle triangle and this is the hypotenuse. So we have AC square is equal to AB square plus BC square according to the Pythagoras theorem. So this is according to the Pythagoras theorem. And now we can use this value of AB square plus BC square over here. So now we know that AB square plus BC square is equal to AC square. So we can simply write AC square divided by AC square, which is equal to 1. And there you have it, that sine square theta plus cos square theta is equal to 1. So sine square theta plus cos square theta is equal to 1. Okay, the next identity we're going to look at is sec square theta minus tan square theta is equal to 1. Okay, now let's derive this. So let's take the LHS first. LHS is sec square theta minus tan square theta. And let's draw a triangle again. This is A, B, C, and this is theta, and this is 90 degrees. So sec square theta, if you remember that sec square theta, sec theta is equal to hypotenuse by adjacent. So that over here is equal to BC by AC. AC by BC. So AC by BC, the whole square, minus tan square theta. Tan square theta is opposite by adjacent. So tan theta is equal to opposite by adjacent. So that over here is AB by BC, the whole square. We can simplify this. We get AC square by BC square minus AB square by BC square. And we can group them together. You'll get AC square minus AB square by BC square. Now again, we're going to relate the value of this to the Pythagoras theorem. So from there we learned that AC square is equal to AB square plus BC square, where AC is the hypotenuse. Now we can rearrange this equation as AC square minus AB square is equal to BC square. So we're just shifting the AB square over there. So now we're going to use this equation, and we know that AC square minus AB square is equal to BC square. So we can substitute this value over here as BC square. So BC square by BC square, which is equal to 1. And that's the other identity, that sec square theta minus tan square theta is equal to 1. Now the last one which I'm going to show for today is pretty similar to this one, and it's cosec square theta minus cot square theta is equal to 1. So again, let's take the LHS. That's cosec square theta minus cot square theta. Now let me quickly write down the formula for cosec and cot. So cosec theta is equal to the hypotenuse divided by the opposite side, and cot theta is equal to the adjacent side divided by the opposite side. So again, I'm going to draw a triangle over here, ABC, where this is theta. So over here we can write it as hypotenuse, that is AC, by opposite, which is AB, the whole square, minus BC by AB, the whole square. So this becomes AC square by AB square minus BC square by AB square, and that becomes AC square minus BC square divided by AB square. And now if you're pretty confident with the Pythagoras theorem, you'll know that AC square is equal to AB square plus BC square, and we can rearrange this as AC square minus BC square is equal to AB square. and we can use this equation over here. So AC square minus BC square we found out to be AB square, so we can just substitute it over here and you'll get the answer as 1 again. And that's the last formula, that is cosec square theta minus cot square theta is equal to 1. So now I'm just going to write all the formulas we learned today, all the identities. So one was tan theta is equal to sine theta by cos theta, and then cot theta is equal to cos theta by sine theta, and the other identities are sine square theta plus cos square theta is equal to 1. Now we can rearrange this identity in two other ways, that is sine square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sine square theta. And the other identity we had learned was sec square theta minus tan square theta is equal to 1. And similarly, we can rearrange this to write sec square theta is equal to 1 plus tan square theta, and tan square theta is going to be sec square theta minus 1. And the last formula which we had learned was cosec square theta minus cot square theta is equal to 1. Again, we can rearrange this and write cosec square theta is equal to 1 plus cot square theta, and cot square theta is equal to cosec square theta minus 1. And these are all the identities or the formulas which we have learned today. Thank you for watching.